This presentation's on pulleys. Please be patient. It's the first time I've ever done something like this, so we'll see how this goes. So a pulley is a lever consisting of a wheel. It has a groove for a cable or a rope, and it's used to change the direction and the magnitude of a force exerted by a rope or a cable. There are two types of pulleys. There's a fixed pulley that has a mechanical advantage of 1, and it just changes the direction of the force. The effort force goes down and the resistance force goes up. The movable pulley is a second class lever, and it has an IMA of 2. The force directions stay constant. On the fixed pulley, it's important to remember that you're going to pull down to move the resistance up. On a movable pulley, you're going to pull up to move the resistance up. To have a mechanical advantage of 1, the fixed pulley, you get exactly the amount put into the system as you get out of it. So if I pull down with 10 pounds of force, I am pulling up 10 pounds of force. With the movable pulley, if I am pulling 20 pounds of resistance, it will only take me 10 pounds of effort. Here my writing is worse than it has been so far this year, but we have pulleys in combination. You can see that I have movable pulleys there and fixed pulleys here. All three of these are going to be movable pulleys. If we look at the pulley on the left, it starts with 80 pounds. That's our resistance force. This cable is going to carry 40, and that one's going to carry 40. When we get up here, this cable is going to carry 20, actually, not 40. It's going to carry 20. So there's the 20, here's the 20. When I move up to the next one, it's going to carry 10, and this one will carry 10. So for this pulley on the left, we have mechanical advantage of 2 times a mechanical advantage of 2 times another mechanical advantage of 2, since all three are movable. So it's going to have an IMA of 8, which you can see by going from 80 over 10 gives you 8. For the pulley system on the right, I have two fixed pulleys, each having a mechanical advantage of 1, and then these two down here have 2. So I do 2 times 2 times 1 times 1. Which will give you a mechanical advantage of 4. So if I throw an 800-pound weight at the end, I have a mechanical advantage of 4. It takes 200 pounds of effort. So to do the mechanical advantage that we have done before, as far as the actual mechanical advantage, we have our resistance force over our effort force. So if I have an 800-pound resistance, 230 pounds of effort, I do the 800 over 230, and it gives me 3.48. To find efficiency, I take my AMA, my actual mechanical advantage, and divide it by my ideal mechanical advantage. So that's 3.48 over 4. So for kind of a review, here I have a movable pulley. This is a fixed pulley. The fixed pulley has a mechanical advantage of 1. The movable pulley has a mechanical advantage of mechanical advantage of 2. So pulleys in combination, or block and tackle pulleys, are a compound machine, which is what this is here. To calculate the mechanical advantage, you take the mechanical advantage of each of the separate pulleys and multiply them together. Now I know this presentation is less than 5 minutes, and I threw a lot of information in it. The whole point of doing it this quick, however, is so that you can pause it, copy down what you need to, and move at your own pace. Sure hope this helps you out. please let me know how I can do it differently the next time.